Hey everybody, thanks for having me. I'm really excited to be here at Intuit talking about JavaScript, especially the isomorphic variety. It's really cool that I've been learning more from y'all that you guys are moving towards Node.js in a big way, which is pretty exciting. It's really neat to see big enterprise companies such as yourself and the ones in the financial industries embracing these new technologies. I think we'll see a lot of cool things happen in the years to come. So, I'm Spike. I'm a front-end engineer at Airbnb, and I do mostly JavaScript and Rails and stuff like that. I don't have a beard anymore, but you can follow, if you want, you can follow along the Airbnb Twitter handle. It's Airbnb Nerds, and that's where we tweet about all things related to Airbnb engineering. So we're going to talk about isomorphic JavaScript. Here's the agenda. The first item is why. Why is isomorphic JavaScript an interesting concept? Secondly, we'll go over some examples of isomorphic in use today that you can go check out. Other companies using this in the wild. And then finally, we'll go into details about how you can write isomorphic JavaScript. So we'll go through some coding examples and get into the nitty-gritty a little bit. So first, why isomorphic JavaScript? And to answer this question, we have to first answer what the heck is isomorphic JavaScript? What is this big fancy word? I think it was mentioned this morning, but basically, all it means is JavaScript code that can be shared between different environments. JavaScript code that can be shared between environments. And I'm a web developer, so I'm really just interested in sharing code between the web browser and the server. So platforms like Chrome or Safari, and then on the server side, Node.js. But there are a lot of other JavaScript runtimes, JavaScript platforms out there today, besides just the server and the client. So a big one would be native apps. iOS, Android can run JavaScript. In fact, that's the basis of how React Native works, if you've heard of React Native. They embed a JavaScript runtime directly into the native app itself, which allows a lot of really cool things. And then for those of you who love the JVM, there's Narwhal. Narwhal is the JavaScript platform that lets you execute JavaScript in a Java environment, basically. Turns out that there doesn't appear to be a real Narwhal logo, so I found this, which felt appropriate. And you may have heard of Rhino, which was another animal with a horn. That was the previous incarnation of this tool. Narwhal is the version for Java 8, which is much better, much faster, and a lot of companies are using that. For example, SoundCloud uses that to render some code on the server. All right, but we're going to just focus on sharing code between client and server using Node, because it's simple and it's really relevant. And that's what I have experience with. So the word isomorphic, it sounds like a big scary word, but really it just means same form. So being able to, I think the dictionary definition is corresponding or similar in form or relations. So same form. And this term isomorphic JavaScript was coined in 2011 by Charlie Robbins, who is the CEO of Nodejitsu, which was a New York City-based Node.js company. And in this blog post back in 2011, entitled Scaling Isomorphic JavaScript Code, this is really the first time that someone had talked about application patterns that are useful for sharing code between Node.js and the web browser. And when I read this, it really set off a lot of light bulbs in my mind, and I was really determined to figure out how to learn more, and that's where this all started for me. Now, not everyone is in love with the term isomorphic JavaScript. It gets a lot of flack out on the interwebs, and so if you can I'll deflect all of that over to Charlie, who coined it. But this is an example of Dan Shaw. He's kind of a famous Node.js person around here, and he jokes that every time I say the word isomorphic, he fines me $5. And so this is an example of that. And as recently as this week, Monday, there's been a lot of controversy on the web about that name. And Michael Jackson wrote a blog post. No, not that Michael Jackson. Michael Jackson is a React.js person in the community he does a lot of teaching about React. And the React community is really interested in Isomorphic JavaScript. But he likes the word universal JavaScript instead, and he writes a treatise of why it should be called that instead. So, take the name with a grain of salt, but I find it to be very useful to describe this concept. So we'll go with that. So let's take a brief detour through the history of web apps so we can get some context about how we arrived at isomorphic JavaScript today. So in ye old web app, circa 1990s through the 2000s, this is kind of what it looked like. It was fairly simple. Your backend, which could be in any language, it could be Java or Ruby or Python or whatever, Perl, would have the bulk of your application. So your view layer, which is rendering HTML, your application logic, your models, your routing, and a persistence layer, which is responsible for talking with the database and doing all that stuff. And then the client was really thin. The web browser had a little bit of JavaScript in it for DOM manipulation, maybe a date picker or a lightbox or a slideshow, a little bit of user experience related things, but nothing meaty. And this was for a lot of reasons. One of the reasons is that web browsers weren't very fast. JavaScript runtimes weren't very fast historically. But in the last few years, around 2011, we started to see the rise of fat client apps, which today we sometimes call single-page apps. And this was really exciting for us front-end engineers because we finally felt like we could build something interesting. Because as web browsers got more fast, and there's new platforms, the HTML5 application platform, we could start to build our entire application in JavaScript for the most part. So that the view layer, application logic, models, routing, all that we could write in JavaScript and shove in the browser. And it was great. You could click around and it would be really fast. You could use push state and rewrite the URL and all this really cool stuff. And it was also a really nice way of working because there's a really clean separation of concerns between the persistence layer, the backend, which really just turned into like a JSON API, probably, a RESTful API, and the application itself. And that backend could still be in any language. As long as it can speak JSON and HTTP, it could serve to your fat client app. And this approach became incredibly popular. I'm sure you're all familiar and build apps like this today. But more recently, we started to see the rise of isomorphic apps. The first examples came out around 2013, and it's really been gaining steam more recently. And the idea is there's some portion of your app written in JavaScript that can be shared between the client and the server. So there's still some stuff that just happens in the browser. There's still some stuff that just happens on the server. And your backend can still be Perl or COBOL or something, as long as it speaks JSON. But then we introduce a JavaScript runtime on the server side that can share some of the same code with the client. And in my opinion, this is really all about the view layer. The view layer is the real interesting part about this, and the reason to do it because one of the goals is to be able to render your app on the server side or on the client side. Generate HTML on either side of the wire. So that shared view layer becomes really critical. And if we dive into that a little bit, the view layer is really composed of a few different components, and each one of those components needs to be isomorphic. It needs to be able to be rendered on both sides. So the most basic part of it is the markup, generating HTML or DOM. You have to do that on the server and on the client. But also data presentation. So anything that takes that raw API response and formats it into something pretty so we can hand it to the view or to our templates, that part needs to be able to execute on both sides. And also our internationalization, whatever provides the translated strings for our views. And date and currency formatting, and URL formatting, basically, etc. Anything else that is used to populate your views needs to be able to run on both sides if you want to have that shared view layer. I see two main categories of isomorphic use cases. The first is what we've been talking about, single-page apps that can be fully rendered on the server. So to any deep link of your app, any route of your app can be rendered on the server side. And I think that's the more common use case for people these days, and it's the simpler use case. But if you get really ambitious, there's another use case, which is to build really ambitious apps that share logic between the client and the server to accomplish novel things. So that's quite broad. We'll touch more on that later, but you can imagine once you can share application code between both sides, you can do some really interesting things. So why would you go to the trouble of embracing this idea? And there is some trouble. It does enforce some constraints on the way you build your apps. So to me, the number one reason is performance. And I think Steve Souders touched on this a bit this morning. But basically, your initial page load speed is way faster. Although, it's really about the perceived performance. Your window load event might not happen any sooner. Might happen a couple milliseconds later. But the perceived performance is drastically faster because the user sees the UI on the page more quickly. And I'll get into that in more detail. Another reason might be SEO. And this is the first reason that we really started looking into this problem, to be honest, is so that our single-page apps could be crawled by web crawlers. Because we were building backbone apps on top of Ruby on Rails, and we would find ourselves basically duplicating some of those views in a really naive way into our ERB templates on the server side, just so that Google could crawl them, which, they're out of date. It's just not a really great way to do it. Now, there's an asterisk next to this point because we've learned recently that Google's web crawler, for example, is actually a headless WebKit browser. So Google can index single-page apps because it'll download all the JavaScript and parse it, and it's basically a web browser that is really sophisticated. However, you may forget that Google is not the only web crawler out there, the only search engine that's relevant. There is a long tail of other search engines, web crawlers that aren't as sophisticated, so this could still be a concern for you. Flexibility could be another reason as well. So you can potentially choose if you want to run a certain piece of your app on the client or the server, and this really is dependent on your use case, like whatever business application you're going for. So maybe it's you want to be able to render a PDF on the server or the client, or maybe you want to generate some image using canvas tag or whatever it is. That flexibility to run it on either side of the wire is a really interesting idea. And finally, maintainability. So when we first started building single-page apps with Backbone on top of Rails, we found that we had to duplicate a lot of our Ruby code into JavaScript. So the simple stuff like date formatting or even like username formatting or all sorts of view logic, we had to duplicate and maintain in 2 different languages, which is a huge pain in the butt. And so it would be nice to not have to do that. So let's look into performance a bit more. So I'm going to show you a little waterfall graph of the way a client-rendered app, a single-page app, is downloaded and processed by the browser. So the first thing that happens when your browser makes a request to your server, which is going to provide your single-page app, it'll download a skeleton HTML page, so some sort of basically empty index HTML with a placeholder div, which is where you're going to insert your app once it renders. And that can happen pretty quickly because it's not doing much. But then your browser will download the JavaScript. Each script tag it encounters, it'll go fetch that over HTTP and download it. And then your browser will evaluate that JavaScript and parse it, which can take a couple hundred milliseconds if you've got hundreds of kilobytes of code and maybe an older device or something. And then sometimes, and only then, we'll even go fetch data from the API. Now this is less of a concern these days because we can use the HTML5 history API, but if you're using hashes in the URL, like the hash bang, remember when Twitter had a hash bang in the URL? The hash is not related to HTTP at all. It's not in the spec. The hash is a browser feature for letting you anchor down the page, and so it's not even provided to the HTTP request to your server. So after each of these steps happens, then you can render your HTML using templates on the client side, and your user will see the content. So all that has to happen before your user sees the pixels being drawn on the page, right? And this is even worse on mobile because there's high latency connections, low bandwidth connections, and low power devices. And on mobile, every additional HTTP request that you introduce means it's more likely to be dropped or time out or take a long time. So this gets really difficult on mobile. So let's look at a server rendered app. And this could be an isomorphically rendered app, or this could just be the app of yesteryear, your typical like simple Rails app. So the browser will make the request, download the full page of HTML, and then the user sees the content. Very simple. But if you put your script tags at the bottom of the page, your user can already see the page while your browser goes and downloads all that JavaScript. Maybe there's multiple files. Then it'll evaluate it and parse it. Then somewhere over there, your app like initializes, like window on load happens and all that. But your user can already see the page. They can already interact with it. They can click on a link. They can type in a form field, and they can read the page. So that's huge. Like that delta between these two approaches is giant. And to go back to the Twitter example, around 2011, 2012, they rewrote their entire web front end from a single page app to a server rendered app. And they were so ahead of the curve. If you're like me, you were so excited to see that Twitter was using hash bangs in the URL and client rendering and so cool and wow, they're really advanced. But it turns out that they were really feeling the performance implications of this. And they did a lot of research, and they defined a metric called time to first tweet, which is basically the time it takes until you can see the first tweet on someone's timeline. And they found that by moving back to server rendering, that was reduced by a factor of 5. So the perceived performance was 5 times greater, which is huge. I mean, if you're trying to sell a product to somebody or have somebody continue to use your app or anything, that performance is critical. And so they spent a year and 40 engineers basically rebuilding their app to do server-side rendering. So to me, it really, at the end of the day, comes down to performance. While these other reasons are nice to have as well, but it's all about performance. So let's show some examples of isomorphic apps in the wild today. So the first would be Flickr. So Flickr is owned by Yahoo these days, and they recently rewrote their app to be isomorphic. And so if you land on their search results page and you click onto one of these photos, it rewrites the URL, renders client side. It's real snappy. But then if you refresh the page, this entire page of HTML is rendered on the server side. And Flickr did this using Yahoo's Mowdown libraries. And so mowdown is just their code word for a bunch of related small node modules that they can use to do this. And it's basically based around Express, which is the node, one of the node HTTP servers. And Yahoo was one of the first to really explore isomorphic JavaScript. They had a project called Mojito, which they open sourced in 2012. But Mojito didn't really get a lot of traction. It suffered from something that I think affects a lot of first movers in the new technology. So they had to solve all of the problems at once. They had to solve package management and all these little problems. And so it was very monolithic, and it was very tied into Yahoo's YUI frameworks. And so it didn't really get any adoption outside of Yahoo. And so their second pass at it was Mowdown, which is a bunch of small modules. So Flickr does this. Instagram does this. They actually just redesigned their photo page, so I need to update my screenshot. But Instagram is a similar story. The first page would be rendered server side. You click on a photo, it would re-render in the client. You refresh, it would re-render on the server. And Instagram was one of the first apps to really use React a few years ago. So what's interesting about this is Instagram is actually a Django app. It's a Python app on the server. But what they did was they ran a node service behind the Python app that they would call out to. They would make an HTTP request to on the server, and that would return back the string of HTML which they would serve to the user. And they could do this with React. So there's an asterisk next to this example because Instagram has since moved away from this approach, and from what I understand, partially because there were people who are maintaining this app don't have much familiarity with Node, and they decided to move away from it. However, we're actually moving towards a very similar approach at Airbnb, which I'll get into later. But what's interesting about this is that you don't have to have a full Node stack to take advantage of this. So Airbnb, this one is close to my heart. This is the Airbnb mobile website, m.airbnb.com. And it's the same story as before. The first page is server rendered. You click a link, client rendered, refresh, it'll be server rendered. And we open sourced a library called Render, which came out of this experience of building our mobile web app. And basically Render is a small library that lets you use Backbone and basically build a Backbone app that can also be rendered on the server side using Express. So you can check it out if you'd like. It's on GitHub. And I'll talk more about how this works later. Okay, so those first three examples, those are examples of single-page apps that can be rendered on the server, that first use case. These next examples are the ambitious, novel applications. So who's used Asana? Is anyone, you all are familiar with Asana? It's a task management app. It's pretty freaking neat because it's very fast. It's all real time. If someone else is editing next to you in their web browser, you'll see the updates happen. It's got really good offline support. It's real snappy. It's pretty novel. What's crazy about Asana is that their entire application runtime is synced between the client and the server. So we normally think of HTTP as being a stateless protocol. A web request comes in from any user. It gets farmed out to any web server based on which one is available to serve the next request. But what Asana did is they built a stateful HTTP server, and they run a separate node process on the server for every single user session. And so a request comes in from that user, and it always goes to that same server process. And the reason they do this is so that they can accurately model the state. The state on the client, they have an accurate model of that on the server. So as you click around the app, there'll be views being executed and things happening, events firing, all this stuff. It syncs that with the server side. The server will execute all those same flows. It'll throw away the HTML. It doesn't care about that. Funny enough, it actually doesn't render on the server. It could probably. And what it holds on to on the server side is the state. So it's got a full picture of the user's state on the server. And if you think about that, that's not something we really have typically in web apps. the server doesn't know at any given moment what the state is on the client. And this allows for some cool features, like really smart loading. So if you click into, let's say you click on to a project, the server knows exactly which objects, which models you already have loaded, and it'll only fetch the delta. And this is incredibly ambitious, and Asana started working on this, I think around 2010, 2009, 2010, before Node.js existed. So Node was created in around 2010 by Ryan Dahl. And the Asana team, which happens to be founded by Dustin Moskovitz, who's the youngest billionaire in the world. He was the one in the movie The Social Network who was in Mark Zuckerberg's dorm room roommate. He's a co-founder of Facebook. So they have a lot of runway. And they were able to take their time developing, researching novel solutions. So they had this idea that they wanted to take V8, which was the JavaScript engine in Chrome, and hook it up to the web. So there was a precursor to Node.js called V8 CGI. Not a very sophisticated project, but it allowed them to iterate on this idea. They've since migrated to Node, but all that's just to say that not all of us have that kind of runway, those kind of resources to spend years researching before we ship a product. So Asana is kind of alone in accomplishing this. However, there's also something called Meteor. Y'all maybe have heard of Meteor. So Meteor, interestingly enough, was started by some of the same people who worked at Asana previously. And in many ways, I like to think of it as an open source version of the Asana toolchain, the Asana platform. So Meteor is Node.js, and it's a real-time app framework. It's all based around real-time. It enforces a lot of constraints on the way you build apps because of the interesting ways in which it can run your code on the client and the server and fetch data and stuff like that. So all this is to say that isomorphic JavaScript is a spectrum. And your app can kind of fall anywhere along this spectrum depending on your goals. So let's say on one end of the spectrum is maybe just small bits of view layer, a few templates, a few bits of logic shared, a few functions shared. Maybe you just share underscore or something. And an example of this would be the Instagram, because Instagram just shared its view layer. Or on that side of the spectrum, you could have your entire view layer shared, all the application logic, all sorts of state shared, and that would be the Asana example. And on this side, you don't need many abstractions to make this work. But the further you go along this spectrum, you need to create more and more abstractions to conceal the fact that the client and the server are actually very different environments. They have different requirements. The way that they interact with HTTP is different, and cookies and redirects. So we'll get into a few of these abstractions, but basically this gets a lot more complex the further you go along that spectrum. And I would say it's kind of diminishing returns. Depends on how ambitious you are, but I think there's a sweet spot in there where you get a lot of the benefits without having to reinvent the wheel. So let's talk in more detail about how to isomorph, how to write code that can satisfy this. So I see another two categories of isomorphic code. One is environment agnostic, or it can be shimmed per environment. So it can be environment agnostic or shimmed per environment. Let me explain. Environment agnostic code, it doesn't depend on any browser-specific properties, like the window, or any server-specific properties, like the process object or request.cookies or anything like that. And an example of this would be Handlebars. Handlebars is a templating library. And Handlebars just deals with primitives, functions, objects, strings, numbers. So it can be executed in any JavaScript environment. And so in this example, you see that we have a template, which is a string. We call handlebars.compile, pass it that template. That gives us a function that we can execute. And then we can execute that function and hand it some data, and we get back a string of HTML. So that works really well on the server and on the client without much special work to make that happen. So the next category is shimmed per environment. So these are libraries that provide shims for accessing environment-specific properties. So a module can expose a single API for both environments. So for example, if you were building a routing library, you would need to abstract out the difference between, in the client, accessing window.location.pathname, but on the server side, accessing request.path. But you still want your module to expose the same API for both sides. So the consumer of that module doesn't have to know. So my favorite example of this kind of module is called SuperAgent. And SuperAgent is an HTTP request library. So in the client side, it's an alternative for like jQuery.ajax. And on the server side, it's an alternative to, say, the Node's native HTTP module. But basically, it allows you to create HTTP requests. So in this example, we're making a GET request, we're passing it a path, and then we're sending the request, and we pass it a callback, and in the callback we can access the response. And so we can look at the response status, the response body, the headers, all of these things, using the same API in the client and the server. And so the way this works under the hood is there's two completely different implementations. There's one that uses XML HTTP requests in the client side, and there's a Node version. And they actually don't share any code at all. But when you use this module, you just use the SuperAgent object and it works. So let's talk about some of the abstractions that you'll run into. So an obvious one is cookies. So in the client side, if you want to set a cookie, you basically just set document.cookie equals, and you pass it a string, some sort of serialized cookie string. And that serialized string has a name, a value, and some metadata. But on the server side, setting a cookie is actually a response header, an HTTP response header. So you'll say response.setHeader, the header name is setCookie, and then you use that same cookie string, that same serialized string. And you can imagine why you might want to send cookies on the client and the server, right? In response to user interactions, authentication, all sorts of stuff. Redirects is another example. So on the client, you could do a full page redirect by setting document.location.href, or you could do a fancy push state redirect using window.pushState. But on the server side, we're sending a 302 or a 301 response to the client. And so in Express, you would say response.redirect. So let's go ahead and write some code. Let's show how we can write a module that abstracts the setting of cookies, but provides the same API for client and server. This is a really nice, well-encapsulated example for setting cookies. So we're going to create a function called setCookie, and we're going to give it a name for the cookie and a value. And in the client side, this will turn into document.cookie equals, then the string. And on the server, this will set an HTTP response header. All right? But it gets more complicated because cookies have options. There could be a path option, a domain option, an expiry, all this. And so in this example, the serialized cookie string, it gets a bit more complicated. And when I see that, I think, oh man, I have to re-implement this. Like, this is annoying. There's probably years of RFCs to read. But luckily, someone's done this for us in JavaScript. So NPM, as you're probably familiar, is the Node Package Manager. It's basically a registry where you can publish modules to be reused. And there's a module called cookie. And cookie is used extensively. It's used in hundreds of different other modules, Express, all sorts of things. So it's the canonical way to handle cookies in Node. And on Node, you could just install this module and utilize it. And we can also do this in the client side with the right tools. So there's a tool called Browserify. Has anyone heard of Browserify? It's a build tool. Awesome. And Browserify, among other things, it lets you package up NPM modules for the client side. So it's basically a build tool that lets you write CommonJS, but it also lets you package up your Node modules. And we can use the CommonJS syntax to require our modules in the browser, and then package up those dependencies from Node modules. And there's a little asterisk next to Browserify because there are other tools that do this as well. Webpack is a real popular one these days. And Webpack is like very similar to Browserify, but it's got all the bells and whistles included. So it's got the kitchen sink, or everything but the kitchen sink, I guess. And Webpack is used by Instagram and Facebook and Yahoo and Netflix and other companies. But we like Browserify. So either one works. All right. So there is a little caveat here. It is different on the server. On the server, you can't just set a cookie because it has to be in the context of a particular request-response cycle, right? In the client side, there's only ever one session, so you don't have to worry about that. But on the server side, Node has all these concurrent requests happening at the same time, and you have to know which request response you're targeting. So we're going to pass in as an option to the setCookie function a reference to the response. And so if we were to use this in an Express middleware, and an Express middleware has three options: the request object, the response object, and the next callback. We could do something like this. So you might be wondering, how do we make a shimmed per environment module? If we were to create a setCookie module, how do we tell the client and the server to do different things? Because there's different implementations under the hood. The secret relies in the browser field of packages.json. Package.json is the metadata file that's included in every Node module. It has the name of the package, the version, the dependencies, all this. But you can use a special browser field in there, and it will tell tools like Browserify and Webpack how to act differently in the client, how to bundle that up for the client. So if this is our package.json for our new setCookie module, which we're going to create and then publish on NPM for everyone to use, there's a name, there's a list of dependencies, but then we can add browser. And browser can take a few different forms. It can be a simple string. So in this case, if it were just a string, it would swap out the entire implementation for the client side. So when Browserify sees this and it tries to bundle this module, it says, oh, actually, I'm not going to use the normal like index.js. I'm going to just point at lib-client.js. And this is what SuperAgent does, the HTTP request module. It's a completely different forked implementation. But that's a little limiting if you just swap everything out. So you can actually get more fancy here. You can specify an object. So this lets you swap out specific files. So you can encapsulate all of that implementation, all those implementation details in files that are specific for different environments, and swap those out, and then let the rest of your code be shared code. And you can even swap out dependencies. So let's say that for some reason, this isn't actually the case, but if the cookie module had a quirk that didn't work properly in the browser for some reason, but there was another package on NPM called Cookie Browser, then you could swap that out as well. And so this is like a really fundamental building block that lets you compose together different modules together and build an isomorphic app. So we're going to build the setCookie module. And I've already built it. So if you want to follow along or download it later. It's published on NPM, but it's also on GitHub, on my GitHub page. But here's the module structure. So we've got our index.js file. That's like the entry point. That's the main file. And then we've got a lib directory. And in the lib directory, I've got a setter directory. And the setter, that's the implementation of setting the cookie. And there's two files. There's an index.js, which is the default implementation. And then there's the client.js, which is the browser-specific implementation. And then we've got our node modules directory with our cookie dependency inside of it. So here's our index.js, our main file. So we require the cookie dependency. We require our setter. And you may remember that setter is actually a directory. And there's an index.js file. One cool feature of CommonJS is you can require, if there's a module, sorry, if there's a directory with an index.js in it, you can just require it with the directory name. So we require our setter implementation, and then we export the public API. This function that we're exporting is the public API of our module. It takes 3 parameters: name, value, and options. And so what we do is we'll use the cookie dependency, we'll serialize the name and the value and any options into a string, and that string is the same on the client and the server. Then we'll actually set it. Pretty simple. And so here's our node implementation, lib setter index.js. And so here we export a function that takes the cookie string as the first argument, and then takes options as the second argument. And the reason we take options is because we need that response object. And if we don't provide that response object as an option, then we're going to throw an error. But assuming that we have it, we will just set a header called setCookie and pass the cookie string. And the client implementation is very simple. Document.cookie equals cookie string. So our final package.json looks something like this. There's the name, our cookie dependency is specified, and then the browser field where we're swapping out libsetterIndex.js for libsetterClient.js. And it's that easy. And just to like really belabor the point, this setter function is what we're swapping out. Yeah, you can ask a question.
On the client side and on the server.
Sure. So
Can you reiterate what it's just?
absolutely. So the question is, it doesn't actually seem like isomorphic JavaScript because it's different code. It's not sharing that code, right?
Right.
So different implementations. So yes and no, right? Because this whole, we can't really read that. This whole file is shared, right? This same exact code is run on the client and server. But then just this setter is not. So this is the power of it, right? Because you want to create as much shared code as you can. It kind of enforces you to create abstractions that that are easy to work with, and then you want to hide the implementation details as much as possible. And so throughout your code base, you're not always saying if browser, if server, if browser, if server, right? You can kind of centralize that into very specific points. Sound good? Okay. So that's how to build an isomorphic module. Now, I'm going to touch on just a few more points, and the next one is isomorphic rendering. So what do I mean by isomorphic rendering? Basically, if we're going to be able to have a single-page app that renders client-side but also renders server-side, we need to be able to generate HTML on both sides of the wire. Pretty obvious. But also, to do it properly, we need to reattach to the server-generated HTML on the client side. So the server serves up a full page of HTML. On the client side, the page initializes. We need to take that DOM that's already there and reattach to it. And I like to call this hydrating the views. And to illustrate this, here's the search page on the Airbnb for Havana, Cuba. You can stay there. We have thousands of places you can stay in Cuba now, as of a few months ago. So this page is made up of a few different views. There's a header view, there's a search form view, there's a search list view, which is this list of search results, and then this view has a collection. And so the collection is a listings collection. And it's got some parameters, right? So it's got like the search parameters. Location is Havana, Cuba, number of guests is 2, all that kind of stuff. So that's all encapsulated in our collection. And then each one of these list results has a view called search list item view. And each one has a model associated with it. So in this case, we've got a listing model with a certain ID. And then for this next search result, we've got a different model with a different ID, right? It's like a common single page app kind of layout. And then each one of these is another view. So with view hydration, it's kind of the reversed process of view rendering. Because when you're rendering your typical client-side app, you start with a view instance, and then that view instance maybe has a model or a collection instance attached to it, and then you use that to generate the HTML. Right? So you go from your view and model to your HTML, which is simple. But with hydration, you start with that generated HTML that came to you from the server, and you need to create a view instance corresponding with that markup. And you need to create a model or a collection and attach it to that view. So it's this reverse process. And when we attach to that existing DOM, we'll like attach event handlers, we'll create our models and collections and all this. And to illustrate this, here's some simplified markup for this page. So for this search results list, we've got a UL, an unordered list. And we actually decorate our HTML on the server side with some data attributes that allow us to understand semantically what each of these DOM elements represents, what the view is, what the collection is. So we've got a few things here. This is from render. This is an example from render. There's a data view attribute, and it's a search list view. There's a collection name, which is the listings collection. And then this fetch summary property basically is the params. So location is Havana, Cuba, number of guests is 2, all that stuff. Because we need a way of associating our data, our model, with that view once it gets rehydrated in the client. And then for each one of these search results items, we've got a list item, and it's got a view called search list item. It corresponds to a model called listing, and it's got a model ID. So what we do is we actually bootstrap all of this data on the page. We use a bunch of JSON to generate the view on the HTML on the page. We bootstrap into JSON, serve it to the client, and then when we reattach to that DOM, we have to reassociate each one of those views and models with the markup. Does that make sense? This was the hardest thing to build. This was like the secret sauce of render. It took me a long time, but the reason that we have to do this is because we don't want, we can't simply just throw away all the server-generated HTML and then re-render client-side and just replace it all with the client-side rendered HTML. That would be a hell of a lot simpler, right? Because you're always going from view with model to HTML. But the reason you can't really do that is because it turns out that there is state in DOM sometimes. So if you rendered that page on the server, someone started typing Havana, and then your app initialized, and it re-rendered, and it threw all that away and replaced it, they would have lost that state. Not to mention, it would be CPU intensive. Maybe there would be some it would pause and you would notice jankiness. But that's basically not acceptable. So we have to find a way to go the other direction. And I've shown you how we've solved it with render. React has another way of approaching this problem because it has a virtual DOM, but I won't get too much into that. So React ships with this ability out of the box, which makes it perfect for isomorphic rendering. So if we were to compare popular libraries today on the isomorphic rendering, we can compare. So Backbone plus templating library of your choice, whether it's Handlebars or Jade or something, it can definitely generate HTML on the server and client. But out of the box, it doesn't provide a way to reattach to that HTML. You can use render for that, but you have to basically create that yourself if you're just using Backbone. Angular, it can't generate HTML on the server, and therefore it can't reattach to that either. So Angular is not a good solution for server-side rendering. Sorry if you're an Angular fan. I really don't like Angular. This is one of the reasons, but Angular is all based around the DOM. So if you had a DOM on the server, you could do it. And people have done that. There are server-side DOM implementations that you can use in Node, but they're slow, and it just feels wrong. It just feels dirty. Now, Angular 2.0, you may have heard of, is coming out sometime, and apparently they're really re-architecting Angular from the ground up, and it's much more like React, and it will support this when it comes out someday. So it's nice to see that we're all kind of converging. Ember, it can generate HTML on the server and the client. Well, this is all very new. And it can also reattach to that HTML. So as of Ember 2.0, which is coming out this week, I believe, Eric Brehm is speaking at this conference tomorrow morning. He'll probably be talking about this. So as of the last few months, Ember supports this. So Ember uses handlebars. However, they hadn't ever supported the ability to reattach until Ember 2.0. They're replacing handlebars with something called HTML bars. And that's the same syntax, but it uses a virtual DOM under the hood. So it's actually inspired by React. So handlebars is pure string concatenation, right? It's dumb as opposed to the semantic markup, semantic meaning of your markup. But Ember 2 has HTML bars, which is a virtual DOM, which allows you to do this. And so they're calling this feature Fast Boot. It's branded Ember Fast Boot, which just means your Ember app can render on the server. So that's pretty cool. They're getting on the bandwagon. The Ember team hates the word isomorphic, so they don't use it, but it's nice that they embrace the concept. Okay, React, it allows you to generate markup on the server and on the client, and it can reattach out of the box. It works. It's perfect for this. And Meteor, funny enough, does not yet support server rendering. It's on their roadmap, apparently. They're rewriting their view layer, so it will be possible. But up till now, ironically enough, they don't do server rendering. So if you were to make a decision about which library to use to do your server rendering, I think that React is the best choice for an isomorphic app, and this is what we've moved towards. However, there are now options as of recently. Oh, before I get to that. So there are a lot of big players that are investing in React. Facebook, obviously, it's a Facebook tool. Yahoo is moving towards React. Their new Yahoo Mail product is all isomorphically rendered React and Flux, which is really cool. Netflix is using React and rendering on the server. But very soon, Ember will be another choice. And this is good that there's more options. So Ember, if you were to compare Ember and React, React is just the V in MVC. It's fairly well scoped, just V rendering, whereas Ember is like a fully fledged application framework. And there are pros and cons. It depends on the needs of your organization, the needs of your team, but they're both good. And I don't know if I can say their name because it's not public yet, but a big successful company in Mountain View not too far from here, is moving towards Ember with fast boot. And so they will be re-architecting to have server-side rendering of a SPA, of a single-page app. It starts with an L and ends with an N. So I don't know. It's word on the street. I think they're trying to have a big press push about it, but when Eric is here tomorrow, Eric Brehm, you can ask him about it. So you all are in good company. You have a little competition, neighborhood competition. So I think my time is about out. So I'm going to skip the next few slides. You can find them. I'm sure I'll send out the links. Thanks.
I did want to point out that Spike's slides are on the QuickBase for his presentation, so if you want to go back and go through them again, you can check them out there. Also, when Intuit TV finishes archiving all the videos, you can go back to his presentation on QuickBase and get that information as well. Do we have time for, I think we have time for a question.
Yeah, we got a few minutes.
Okay. Who's got the first question?
I've got some treats that I'll give you if you ask a question.
My question has to do with security between the code that runs on the client and the code that runs on the server. How is that being handled? Is there some kind of zone system or security levels that your library has?
There's not, I don't think there's like a single answer to that, really. I mean, all the general web application security things apply. XSS, CSRF, all that kind of those protections to consider. I guess the only other thing to think about would be that now code that you are used to writing for the client can also run on the server. So there are ways of sandboxing in Node. It's slow, but I don't think that fundamentally there are large security implications of this approach. Please let me know if I'm wrong.
I think Bill Scott also addressed that last year when he gave the keynote on Node. Bill Scott from PayPal.
Thanks for asking a question. Here's a pen for you.
So you mentioned people who are fans of the JVM, and I think you mentioned a technology. What's the use case for sticking with the JVM and doing some of this stuff?
Good question. So some people love the JVM, and they have invested in it a lot, and they know it and they understand it. And so for them, moving to a new tool like Node is scary or unnecessary. So with Narwhal, you can embed a JavaScript runtime directly in your JVM. And so I've been talking to the people at SoundCloud and SoundCloud.com on the not the user-facing side, but on their like business-facing side. They do server rendering with React and Flux in Narwhal. And one of the reasons they do that is because they have a Scala backend. And there's really tight integrations that they can expose between the Scala and JavaScript in ways I don't fully understand. But I think that'd be one reason.
So in terms of development, if you're writing it like in Node and you don't actually visually get to see it in the browser, how does that process go? Because usually you just write the JavaScript and see it rendered, and it's really easy to debug as you're working.
Sure. I mean, it's kind of the same. You know, you edit the code, refresh, and you should see it there. There are, like, you do have to, debugging can be more difficult because if you accidentally type window or something on the server side, it might explode. So I think just the typical Node debugging tools will help you. There's a Node inspector project which lets you point basically Chrome DevTools at your Node box. And so it can actually get a little confusing because you can set breakpoints both in Chrome and the client-side code and on the server-side code and hit both of them at different times. But there's a lot of Node tools that will help you debug.
One other question. So, like for the cookies thing that you just wrote, a thing, it would seem like there's a lot of these. Are there like packages already available that have done pretty much all of these common functionality things?
Good question. Probably. I don't know that there's like a single list or registry of them. that's been one of the harder things about Node is figuring out which modules are out there and which are good. But this is something that Meteor tries to solve. They've got their own build, their own module registry, their own build tool called IsoBuild, which you can check out the slides and learn more about it. But IsoBuild comes from Isomorphic Build Tool, and it's a tool that you can use outside of Meteor, but it specifically addresses that problem, basically.
Thanks.
All right, that might be all the time we have.
Give him a round of applause.